Hi everyone, my name is Dr. Saida Falafini from Cal Poly Pomona. In this video, I'm going to talk about an example related to decision tree. This example is about Disney Corporation. Disney is having a new show called Lion King, and they are going to tour this show nationally. The cost of touring the show nationally is about 12 million. But there is only 50% chance that this national tour is going to be a success, and in that scenario they will earn $20 million, and also there's 50% chance that it's going to be a failure. In that scenario they only will earn $10 million. So on the other hand, Disney can do a preview of the show to get a sense of how it's going to be received. The cost of doing the preview is $P, so we'll talk about the P value. So just let's assume the cost of doing the preview is $P. And if the preview is going to be received favorably, for sure the national tour also will be received favorably. If the preview is not going to be received favorably, then there is only 10% chance for the national success. And the historical data has shown that when they preview a show, there's always 50% chance for success and 50% chance for failure in that preview. So now Disney wants to know what is the right decision to make. Should they go ahead and do the tour nationally or not, and then if they have to do the local preview or not, and how basically they have to deal with this problem. You also want to know the expected value of sample information. Okay, so this is the summary of the problem that we just went through. I also have put the summary here on the top so that we can use it as we are going to develop the decision tree. So I want you to think at this point, what is the first decision that Disney has to make at this point? The first decision that they have to make is, should they go ahead and preview the show or not? Okay, so since that's the first decision, we are going to use a decision node to show it, and the two possible outcomes, the two possible decisions are doing the preview or not doing the preview. Okay, let's assume they do the preview of the show. Okay, what are the two possible outcomes? The two possible outcomes are seeing the favorable results or unfavorable results, each one of them with 50% chance. That's what we learned from the problem statement. And obviously, since these are potential outcomes of a decision, we are going to use an event node to show those. Okay, so let's assume they are going to do the show, and the results to do the preview, and the results are going to be favorable. What is next? So the next thing is making a decision again. What is that decision? Should we go ahead and do the show nationally or not? Okay, so do the show or not do the show. And again, since this is a decision, we are going to use a decision node for that, and the two possible actions they have in front of them is doing the show or not doing the show at all. Okay, but what if they see unfavorable results from the preview? So what are the options then? So in this scenario also, if they see unfavorable results from preview, they still can make the decision. Are they going to do the show or not to do the show at all? Okay, so what is next? So let's assume they see favorable preview results and they decide to go ahead and do the show nationally. Okay, so what is next? We potentially can see two possible outcomes. Either we see a national success or a national failure. Since these are two possible outcomes, we are going to use an event node to show those. Okay, so and what are the probabilities of seeing a national success or a national failure? As we learned from the problem statement, if we do a preview and it's favorable, for sure we will see a national success. So that's why the chance of seeing success is 1 and the chance of seeing national failure is 0. Okay, And if we just decide to cancel the show and not go ahead with the national tour, that's the end for us. And similarly here, if we see unfavorable results for the preview, again we may decide to go ahead and do the national tour. In that scenario, we again may observe a national success or a national failure. And what are the probabilities of each one of these? We again know from the problem statement that if our preview is not favorable, we only have 10% chance of success. So that's why the chance of success is 0.1 and the chance of failure is 0.9. And again, in this scenario, when we see unfavorable results from the preview, we may decide to cancel the national show completely and not go ahead with that. How about this decision? We decide to not to do the preview at all. Okay, so in that scenario, we still have to make one more decision. Are we going to do the show nationally or not? Okay, and what if we decide to do the national show? We may observe a national success or a national failure. And what are the probabilities of each one of them happen? We know from the problem statement that there is always 50% chance of success for the national show and 50% chance of failure. Okay, so if we, without doing any preview, if we just go ahead and do the national and if we do the show, we have 50% chance of success and 50% chance of failure. And if we decide to not go ahead with the national tour, then that's the end for us. Okay, so this is the structure of the decision tree. So what is the next thing that we need to do? We need to put the cost or the value associated with each one of these terminal branches. Okay, so what is the value associated with the first branch? So in the first branch, what is happening? We do the preview, we see favorable results from the preview, we decide to go ahead and do the national show, and then we see national success. Okay, so what are the values associated with it? Since we do the preview, the cost of the preview is P, and since it's a cost, I'm going to put it as minus P. And then we see favorable results, and then we decide to go ahead and do the national show. The cost of doing the show is $12 million. So the $12 million that I again put it as minus is the cost of doing the show. And then we see a national success. So if we see a national success, we earn $20 million. So then I put that $20 million as a positive. Okay, so what is the result? 8 minus B is the value associated with this terminal branch. How about this other terminal branch? For this one, we do the preview, minus P is the cost. We decide to go ahead and do the national show, minus 12 million is the cost. But since we observe a national failure, we observe only $10 million as the profit. So the value associated with this terminal branch is minus 2 minus P at the end when we add up everything. How about this terminal branch? So for this one, we are going to do the preview, minus P is the cost, but we are not going to do the national show. So minus P is the only cost that we incur. And how about these other three terminal branches? For these as well, they are similar to the ones on the top. For example, for this one, we do the preview, minus P, we do the show, minus 12, and we see national success, plus 20 million. Okay, so if you calculate the cost for this terminal branch and for this terminal branch, you will also see these numbers that you see here as well. How about this terminal branch? So here, we are not going to do any preview, so no P cost. However, we are going to do the show nationally. That's $12 million cost, and we are going to see national success. So that's minus 12 million plus 20 million, that's 8 million. And for this one, minus 12 million is the cost of doing the show, but we see national failure. So that's only $10 million earning. So the sum of that would be minus $2 million as a value. And how about this terminal branch? We are not doing the preview, we are not doing the show, zero costs. Okay, so after we draw the decision tree and we specify the value associated with each one of the terminal branches, then we have to go ahead and assign the numbers to any one of these event nodes, because we are going to calculate the expected value of these 4 event nodes. Okay, first let's do the expected value of event node 1, 2, and 3. Okay, how should I calculate the expected value of event node 1? The value of the branch 8 minus p multiplied by the probability of the branch plus the value of the other branch minus 2 minus p multiplied by the probability of that branch. Okay, so for event node 1, expected value of income for node 1 is 8 minus p, because minus 2 minus p is multiplied by 0, so there is only 8 minus p multiplied by 1. How about event node 2? We have 2 branches. These are the values and the probabilities are 0.1 and 0.9. So we are going to multiply the value of the branch by its probability plus multiplying the value of the other branch by its probability, and the sum and the results is minus 1 minus p. And then for node 3, we are going to do the same. Multiplying the value by its probability plus the value of the other branch by its probability, and this is the results. So what we are going to do next is going to put the value, the expected value associated with each one of these event nodes on top of them in the main decision tree. Okay, so we put exactly the expected values of these event nodes on top of them. Okay, so what is next? We are going to just again go backward on our calculations. So at this point, if we are ever at this decision making point, what is the right decision to make? If we make this decision, we have 8 minus p, and if we make this decision, we have minus p. Okay, so definitely this one has higher value because minus p is the same in both. This one has 8 units more, so definitely the value of this decision is more. So doing the show is the best decision here, and the value of this decision node will be 8 minus p. How about here? If we ever are at this decision point, what is the best decision to make? If we do the show, nationally we have minus 1 minus p as the cost, but if we cancel the show, we only have minus p. Which one is larger? Obviously this one, because minus p again is the same in both of them. However, this one has minus 1, it has 1 unit less, so minus p value is bigger, so canceling the national show is the best decision here, and the value of this decision node is minus p. How about this decision node? If we ever are at this decision node, what is the best decision to make? Obviously doing the show, because we expect to see the value of 3. Okay, and then the value of this decision node is 3. Okay, what is next? Next we have to calculate the expected value of this event node. What are the 2 values associated with these branches? One of them has value of 8 minus p, the other one has value of p, and then the probabilities are 0.5 and 0.5. So expected value of event node 4 is 8 minus p multiplied by 0.5 and minus p multiplied by 0.5, adding them together, and this is the results. So again, I'm going to put the expected value of this event node on top of event node 4 in the main tree, and that's what we see. So continue going backward, we are now at this decision node. So if we ever are at this decision node, what is the best decision to make? Doing the preview is the best decision to make, or not doing the preview at all. We cannot make that decision clearly at this point, because we don't know if minus p plus 4 is larger than 3 or not. So but we can definitely say that if minus p plus 4 is larger than 3, then doing the preview is the best decision to go with. Otherwise, not doing the preview is the best decision to go with. So deciding about which one of these decisions is a better one, we have to compare minus p plus 4 with 3. And this is exactly what I just said. If minus p plus 4 is greater than or equal to 3, then we are going to do the preview, okay? And obviously minus p plus 4 greater than 3, meaning that p is less than or equal to 1, okay? That means the cost of doing the preview should be less than or equal to 1 million, okay? And now the other question that we had, if you remember, was that what is the expected value of sample information? For calculating the expected value of sample information, if you remember, we considered the value of this decision without paying anything for the preview, okay? If I do not pay anything for the preview, then the value of this decision is 4, because then I have paid 0 value for the preview. Or in other words, I'm going to add p value to it, because whatever the p value which was the cost of preview, and I deduct that cost initially, now I'm going to put it back, I'm going to return it, okay? And then I compare that with the value of 3, which is the value of this other decision. So for expected value of sample information, minus p plus 4, which was the value of the first decision, I'm going to put back the cost p, which was the cost of preview, and then minus 3, which is the cost of the second, which is the value of the second decision, and that is equal to 1. What does that mean? That means that if you are going to charge this company $1 million or less, anything less than $1 million for this information that you may get from a preview, then they are willing to pay for the preview and do the preview, okay? However, if you are going to charge Disney more than $1 million for the preview, it's not beneficial to do the preview as well.